Good evening, everybody. Welcome to Chem 1211 with your host, me, Dr. White. Tonight, I'm going to be doing the review for Quiz 4. Let me remind you, but before I do that, important announcement from me, the management. Don't forget, hand in your labs. I sent out an email, an announcement about the lab amnesty program. Wherever I hit it, guess I didn't. Here it is. Let's move it back up to the top. Thought I did. Sorry about that. All right. First of all, you should check to make sure any labs that you have submitted, I have graded. And those, we're talking about those that were due last week, not this week, or earlier. Now, I have an amnesty program I'm instituting. You have until the 8th of May at the end of the day, 11:59, that's the end of the day essentially, to submit any labs that were due this whole semester. And I will grade those labs. I will only assess one late point. Now, let me remind you that you need to get 65% of the total lab points to get a C or higher in this course. That's the departmental rule for not only my class, but all chemistry classes. So you need to hand in your labs, and some of you need a lot. If you need any help, contact me. Send an email. If you can't make it to my office hours, I can set up a Zoom meeting to help you out. But you have to get at least 65% of the points to get a C or better in this class. So hand in the labs, and the lab amnesty program will help you. All right, next, let's talk about quiz number 4. And this Thursday, the 24th, I was looking at the calendar I have up here, an electronic one, at 8 a.m. At that time or earlier, I will be emailing you the password for Quiz 4 PDF file. You'll have until the next day, Friday the 25th, 8 p.m., to take Quiz 4 and upload your answers as a single PDF file. If you don't upload it as a single PDF file, like I say in blue there, I reserve the right to subtract up to 25 points from your Quiz 4 total for anyone who doesn't follow instructions or doesn't upload it on time. And I will do that. So make sure you submit your answers as single PDF file. All right, Quiz 4 has 4 pages, 13 problems, including 5 multiple choice. It's worth 50 points, and it covers chapters 12 and part of 13, all the parts that deal with solutions, which I'll go over tonight. By the following Sunday, I'll get your scores for the quiz in Blackboard, and I'll email you individually the points you receive for each answer on Quiz 4. And obviously tonight we'll have the Zoom meeting for the review for Quiz 4. So let's get to it. Now, in the lecture folder of Blackboard, there's a file cleverly named, not really, but think of it that way, Chem 1211 Quiz 4 Review. This is an important file that you should be looking at. Also, another file that I want to talk about and will is important information for quiz 4. Now, unlike in the video, which was from a couple of years ago that you've been watching, last semester, department chairman issued rules for all chemistry faculty, including Dr. White, that we are now not allowed to put in things like this that I would put at the end of quiz 4. So if you go to the lecture section of Blackboard and look up Chem 1211 quiz 4, important information, these are things you need to memorize. And some of it you've already learned, I hope, for test 1 and quiz 3. So there's not a lot, but there are some other definitions I didn't include in important information that I expect you to memorize. All right, let's get going. Now, when we talk about solutions, a solution is one compound that's dissolved in another compound, and each compound retains its own chemical identity. It doesn't change. Now, when we talk about mixing things together, that's when a solution is homogeneous. It's the same throughout. Now, when we talk about a solution, there are two terms you should know. One is solvent, and a solvent is the component of the solution present in the greatest amount. Again, a solvent is a component present in a solution that's present in the greatest amount. And all other components or component of the solution are called solute. Now, solution where it's homogeneous, something that at first glance you might say, oh, that's a solution too. It's not, and that's a colloidal dispersion. The particles of one substance are suspended, not really dissolved in a liquid. And it's not a solution. And how can you tell? It scatters light. Oh, it's time for me to show off one of my favorite flashlights. Right. If this were sugar and water, the light goes through it. If this were milk, it's like my hand, which is not really a solution, but you get the feeling, it blocks light because the particles scatter it. By the way, you want to see something cool? It's now red. It's now white. It's got both different emitters there. This is from a gentleman in China, Hank Wang. And unfortunately, because of certain tariffs, I'm not going to be buying flashlights for a long time. Anyways, let's get back to chemistry. Now, what are examples of colloidal dispersion that you should know? Well, one is milk. Another one, and don't try this at home with a flashlight, is blood. And finally, another one that comes to mind is latex paint. And finally, mayonnaise is a colloidal dispersion. Also, some other things. All right, now, important concept of solutions or making a solution is the concept of like dissolves like. Like solutes are soluble in like solvents. What that means is there's two types of, or two ways of identifying a substance. Is it polar or nonpolar? Now, the most polar substance is water. And all salts are polar. Alcohol and all alcohols, like ethanol, which you drink, isopropyl alcohol and rubbing alcohol, are also polar. Things that are non-polar are vegetable oil, interesting enough, dirt, grease, Vaseline, otherwise known as petroleum jelly. And what like dissolved like tells us is polar solutes are soluble in polar solvents. So if I take, another one here that's polar is sugar, otherwise known as sucrose. And if you take water, put in some, say, sodium chloride, table salt, it will dissolve, so will sugar. Now, nonpolar solutes are soluble in nonpolar solvents. Again, nonpolar solutes are soluble in nonpolar. And when you mix, say, something like vegetable oil, I didn't look down here, I give you the list of some polar things and some nonpolar things, and a little hint, know this, hint. But if you take, and I actually had a student do this once in a lab, took some vegetable oil, gave him some Vaseline, and guess what? The Vaseline was soluble in the vegetable oil. Why you'd want to do it, I don't know, but it is. However, the important thing about like dissolves like, if you take something polar and mix it in something non-polar, they're not soluble. So if you take something like water and vegetable oil and you mix it up, it separates because of like dissolves like. All right. Now, when we talk about solvents or solutions, really, an important thing is the solubility of the solute. And that's the maximum amount of solute that will dissolve in a given amount of solvent. You can't put one more molecule. You're at the limit. That's the solubility. Now, when we talk about solutions, there are types of solutions that you should know. One is a saturated solution. That's the solution that contains the maximum amount of solute that can be dissolved under conditions at which the solution exists. Example, temperature. Something is more soluble in certain substances, say in water, when it's hot than when it's cold. The other thing you should know is a dilute solution, which is the opposite of a saturated solution. And a dilute solution is a solution that contains a small amount of solute relative to the amount that could dissolve. Now, really opposite of dilute is concentrated solution. That contains a larger amount, it's a solution that contains a larger amount of solute relative to the amount that could dissolve. You're not at saturated yet, but you've put a lot of solute in the solvent. Remember, solute are the other components. Solvent is the component present in the greatest amount. Now, probably one of the most important things when it comes to definitions is aqueous solution. And in chemistry, when we say an aqueous solution, that's a solution in which the solvent is water. and it's abbreviated by bracket AQ close bracket. That's an aqueous solution. That's where water is the solvent, and it's abbreviated at the end of, and you'll see in a little while, I'll talk about it, bracket AQ close bracket. Now, when we talk about solutions, how much of a solute is present in how much of a solvent? And we have, that's called concentration. Now, in the lecture, I talked about other concentrations, but for my class, the most important one, and in chemistry, is molarity. And molarity, which is designated by a capital M, molarity, which is designated by a capital M of a solution, is a ratio giving the number of moles, and you know what a mole is, of solute per liter of solution. So molarity is moles of solute per 1 liter of solution, not solvent, but total solution. Now, 1 liter equals 1,000 milliliters. And this definition is usually more helpful in the lab. And that is moles of solute per 1,000 milliliters, molarity. Now, let's take a look at the problem section for this quiz 4, which is my practice problems for 12 and 13, chapters 12 and 13. Give an example of colloidal dispersion. I already talked about this. Give an example of a solution you use in your daily life. Well, tea, Dr. White used to be a heavy tea drinker until I had to cut down on the caffeine. I still like tea when I can have some pop. Remember, Dr. White's from Chicagoland, and pop's the carbonated beverage you buy in a can or a bottle, such as Dr. Pepper or Werner's, the good stuff. Air is even a solution. Now here I have, if a solution has 12 grams of KBr, potassium bromide, 10 grams of water, what's the solvent, what's the solute? Solvent is the component present in the greatest amount. That's the KBr. And here water is not, so it's the solute. Now, we talked about molarity. And when you see a capital M between a number and a structure or a formula, a chemical formula, that means molarity. And what does 1.34 capital M HCl mean? That means molarity, moles of solute, in this case HCl, 1.34 moles per 1,000 milliliters. We look at number 7. What does 4.56 times 10 to the third capital M NaCl bracket AQ close bracket mean? And what is the solvent of the solution? Well, whenever you see the AQ in the bracket, that always tells you the solvent is water. That always tells you the solvent is water. And now the other part, capital M, means molarity. And here we have 4.56 times 10 to the third capital M NaCl, sodium chloride. And that tells us there's 4.56 times 10 to the third moles of sodium chloride per 1,000 milliliters. Again, it's better in our class to use 1,000 milliliters instead of 1 liter, because I'm always going to give you, if I give you milliliters, I'm not going to use liters for this chapter. All right, now, when we talk about molarity, one of the nice things is If I have a stock solution, a certain molar solution, I need a certain amount of that solute. I don't have to weigh it out and then dissolve it in that. I just measure out the volume. So let's look at number 8. How many moles of sodium chloride, NaCl, remember that's table salt, are in 125 milliliters of a 3.45 capital M NaCl solution? So what are we trying to find? I apologize, I have it written here. MOLE is mole of NaCl. What are we given? Well, we have 125 milliliters of the solution, and we're given this number, 3.45 capital M NaCl. Capital M tells you that's molarity, moles of solute per milliliters, 1,000 milliliters solution. What that really means, that's why I have the little arrow down here, 3.5 moles of sodium chloride per 1,000 milliliters. So now, to solve this problem, the only number we really have right now is 125 milliliters. We want to get the moles of sodium chloride. And if we had a ratio to convert milliliters to moles, what would I do? I'd use my good buddy, my good friend, unit analysis. Whatever I'm trying to get to, the units go on top of the ratio, moles of NaCl. Whatever I'm trying to get rid of, I don't want milliliters in my final answer, I put underneath. And where do we get the ratio of moles of NaCl per milliliters? From the molarity, which is written like this, 3.45 moles of sodium chloride per 1,000 milliliters. Now, on quiz 3, like my other quizzes in test 1, it will say underneath your name, please use proper significant figures for all calculated answers, and please use 3 significant figures for all calculated for all atomic masses. Now, 125 is 3 significant figures. 3.45, 3 significant figures. Now, the 1,000 is the definition, moles per 1 liter or moles per 1,000. This is an exact number. When you multiply and divide, you get the same number of significant figures in your answer as the number you're multiplying and dividing with the fewest. In this case, 3. You do the math, round it off to 3 significant figures, and the answer is there's 0.431 moles of sodium chloride. Now, I have a couple other problems like that for you to practice, and hopefully you have. Now, in real life, one of the important things we do in the lab is make up stock solutions. And normally they're 500, but I put a little different volume to make it more interesting. How many grams, let's look at 11, of sodium chloride are needed to make 345 milliliters of a 6.789 capital M NaCl solution? So what are we trying to find? Remember, G is grams of sodium chloride. We're given 345 milliliters, and we're given this number, 6.789 capital M NaCl. Oh, capital M between a number and a formula or empirical formula, that means molarity. And what this really means, that's why I have a little arrow down here pointing to this, 6.789 moles of sodium chloride per 1,000 milliliters. Now, if we go back to quiz 4 review, we now need the molarity 2-step. This is a molarity 2-step problem. In step one, we convert the milliliters to moles. In step one, we convert the milliliters to moles. In step two, we convert moles to grams. And step two, which you learned how to do for test one and also quiz three, remember 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight of the compound is the sum of all atomic weights. So if we go back to that problem, step one, we're going to go from milliliters to moles. How do we do that? We have 345 milliliters. And we want to convert it to moles of sodium chloride. And how do we do that? We do a ratio. And you use your good buddy, your good friend, unit analysis, whatever we're trying to get to, the units go on top of the ratio. Whatever we're trying to get rid of, the units go underneath. And where do we get the ratio moles of sodium chloride to milliliters? From the molarity, 6.789 moles of sodium chloride per 1,000 milliliters. That's what this means up here. So we put in the numbers. Again, when you do multiplication, you get the same number significant figures in your answer as the number you're multiplying or dividing with the fewest. Now notice you're going to do two calculations, step one and two. And there are two philosophies, round off at the end or round off at each step. And I'm a round off at each step person, but I'm not going to force you to do that. So I'll calculate both ways. If the answers are different, either one would be correct. But here I'm rounding off at each step, 3 significant, 4, and the 1,000 is exact number. And you get the same number significant figures in your answer as the number with the fewest. I have 3, 4, which is lower, 3. So I get round my answer off from my calculator to 3 significant figures. Now, I have moles of sodium chloride. Is that what we want? No. We're trying to find grams of sodium chloride. And now we're going to do step 2, convert moles to grams, which you learned for test 1 and quiz 3. Hopefully you know for quiz 4. And here we have moles of sodium chloride. We want to get the grams of sodium chloride. We need a ratio to convert that. Whatever we're trying to get to, you put the units on top of the ratio. Whatever we're trying to get rid of, you put the units underneath. And where do we get a relationship of grams of a compound to moles of a compound? And in quiz 4, important review, I remind you, 1 gram of a compound is the molecular weight of that compound in grams. And the molecular weight is the sum of all atomic weights in that compound. So now you're going to have to wait a second because I forgot to open it up. And here we'll have the periodic table that you'll download and use for quiz 4. And we're finding the molecular weight of sodium chloride. Sodium, remember the number underneath is the atomic weight. And for my quizzes and tests, rounded off the 3 significant figures, 22.989 is 23.0 for sodium. Now, chlorine, Cl 35.453, to round off the 3 significance figures, is 35.5. So over here, I have the molecular weight, MW is shorthand for molecular weight of sodium chloride. And the sodium has atomic weight 23.0, chlorine 35.5, add it up, and you get 58.5. Now, on this one, you don't have to worry, but remember, rounding off in addition, you get the same number of significant figures to the right of the decimal as the number with the fewest significant figures to the right of the decimal. I like these special effects. Anyways, there's one to the right, one. That's why we have the 0.5. We put that in there, do the math. This is three significant figures, three. The one is exact number, and you get 137 grams. So if you dissolve 137 grams in enough water to make a total of 345 milliliters, you will get this molar concentration. Now, if you notice, I have here both ways, and you get 137 whether you round off at each step or round off at the end. It isn't always true, but in this case it is. In this case it is. In that case, well, I guess in these problems I picked numbers that did. And here's 12 and 13 for you to work on your own. And with that, I'm done. Remember, I'm no longer giving important information at the end of the quiz, like I said in the video, because of rules that were instituted last semester by the chemistry department chairperson that I and all other faculty have to follow. Don't forget, hand in your labs. Don't forget when you upload quiz number 4, do it as a single PDF file. I like those special effects. And with that, you know what I'm going to do now. First, I'm going to say "Gehen gesund," which is Yiddish, which means go in hell. And finally, I'm going to say bye now. Bye. Stole that from Granny and the Beverly Hillbillies. Bye.